Thanks, Jeff. And just to say this, of the context of this talk is coming out of what Jeff mentioned earlier in the announcement for the talks around the ESG and cyber connections, effectively environment, society, and governance is one of the big themes for a lot of companies. And I guess what perspective we are coming from is the environmental sort of perspective, in particular environments and homes and how they might benefit people or not benefit people when they're terrible. And in the Southwest, as many of you might know, home environments are not great because of various factors, from humidity to pollution and so on. So this is a work that's coming out of a few projects being funded through the last sort of 8 years, from the European Union government to current leveling up funding, also research council money from UKRI and the National Institute of Health Research, because it's always linked in the context of data and sensors, as well as health and well-being implications. And we also work with a lot of partners in the Southwest, particularly social housing providers here in Cornwall, Coastline Housing, as well as Volunteer Cornwall HUK as of care providers, and the council and the Academic Southwest Academic Health Science Network. And we also started more recently working with the actual sensor developers and sensor providers. ACO HomeLink is one of the partners on one of the smaller sub-projects within this bigger portfolio of projects, who are directly working with us to actually learn. They're not necessarily interested in the cyber aspect, and I will talk about some of the questions that come up from our perspective, but they're more interested in how to make their products better. And I guess cyber probably plays a role in that. I just will give you a sort of a insight into two of the a short summary of the projects, two of the kind of research that was going or is going on, and then try to link to questions which relate to cyber, particulars, privacy, and I guess data security. And then how, I mean, I don't know the answers to that, and that's what Joe said. It's probably more of a sort of brainstorming talk for you. And then also maybe how one can link into that, or link this type of approach, like cyber security, as well as ethical use of this type of technology and data in the future. So the Smart Line SenseWell projects, which are both relatively chunky projects which are running over the last 8 years. So Smart Line division was essentially set up in 2016, 15, 16 to kind of help people in the Southwest in particular with challenges they face linked to health and well-being, and how they would be better be using technology to overcome these challenges, and particular in the homes they live in. And so we work with Coastline Housing, one of the social housing providers in the Southwest, who have a lot of tenants who are elderly and don't really know what to do with technology. So one of the big challenges, and it's still a challenge that is going on, but challenges faced by, in particular, people who are not as data or digital savvy as a younger generation, is that they are essentially losing out with the transformation of the health and care services to more digital services and platforms. Excuse me. So the project was started in 2017, and we had about more than 300, about 350 participants living in social housing in the Camden, Pool, Logan, and Red Roof area in Cornwall. And we did do surveys with participants over that period of time, from 2017 to 2023. And we also installed sensors in their homes, essentially recording their home environment, as well as recording measurements from electricity, in some cases also gas and water measurements, utilities in their houses. So the general population of the cohort was primarily in low rent affordable housing, sometimes sheltered accommodation, and also shared ownership. And you can see the rough area plot here where we are looking at. And so this project then essentially wrapped up with European funding, the RDF funding, coming to an end in 2022. And so follow-on projects are now funded by the Research Council, in this case EPSSC, as well as the National Institute of Health Research. And effectively, one of the outcomes from SmartLine and the data which was generated, so one of the sort of initial finding, working with the data or analyzing the data and applying all sorts of different statistical machine learning methods, is how we can actually use that data to identify changes in the occupants' health in specific settings. So, for example, from differences in temperature, humidity, or air quality measurements, but also then trying to understand better what kind of conditions that might link to, and if we can use sensor data to predict anomalies, for example, risks in certain health and well-being conditions, and potentially then also linking that to NHS or care services to actually use that data. So it's kind of the feedback loop between sensing a person's home, using that data for their own purposes, but also using it in the context of organizations which will help people. So I just gave you two examples of how this effectively worked out. And the first thing to kind of introduce there is what sensors actually are being used in these projects, but also generally later on, then what is sort of on the market, what is being sold on the shelf effectively. So when we started in 2017, these sensors were kind of not yet available as sort of off-the-shelf products, but primarily being designed for industrial or kind of company settings. And so we worked with a company called Invisible Systems, which had quite clunky big sensors at that time, which we installed in households, recording these sort of measures in homes, so air temperature, relative humidity, and air quality, particular VOCs, volatile organic compounds, and the particulate matter. And then also utilities data measurements, which is obviously something which is more and more being measured through smart meters anyway, and data sits with the energy providers. But at the time, it is, and still, it is really hard to actually get into this type of data. So these were kind of add-on sensors, which were clipped on, for example, electricity meters, and the cables that come out of meters and record data directly from the circuit inside a house. And then the development of sensors in this space is really quite rapid. So since 2017, until we started a new project in 2022, when we started sort of looking for sensors for the EPSC funded project, these sensors effectively become a lot cheaper, a lot smaller, a lot less energy intensive, and a lot easier to use. And they're now pretty much off the shelf. You can go to a lot of websites and essentially buy them in bulk and get also the access to the data platforms with them, and effectively also dashboard or app technology to look into the data. So the outcome of the SmartLine data set, which was running from 2017 to 2023, is a big data set of these sort of 300 plus properties, up to 4 years in some cases, of continuous data collection, with a fairly high frequency of 3 to 5 minutes. Now we are able to even make that faster. So in the more recent sensor installations, we have 10 to 30 seconds data records. And so the data from SmartLine was published by us in 2023, the UK Data Service, and that one of the big excellent challenges there was actually to make the data accessible in a way that it doesn't violate any kind of privacy issues. So just the kind of cyber challenges intersection, if you like. Data privacy from a research study participant perspective is really an imperative, and universities won't us as researchers allowed to do anything anyway if there is not a rigorous ethics process which looks at all sorts of things, also data and how data would be collected, how data would be used, how data would be shared. And so actually, when I talk about participants, we researchers, we actually don't know individuals, we just know their data, and we also need to be really careful of how, for example, information is shared between the partners who actually know the people, and then if we share information back, what they might do with it. So for example, that's a big issue with the universities take a lot of care about, but funders, they may or want to see that if you're doing a project and it gets funded by X million of pounds, that you produce a product, and they want to see the data that's going to be openly available. And so one of the big tasks, and so towards the end of the project for more than a year, almost a year and a half, was to kind of curate the data in a way that was being able to be published with the UK Data Service, which is sort of offering that. But there is this kind of trade-off between how much of the data you can make available and how much would be too much for people to be then identifiable. So in a way, it's kind of the level of detail in this case starts making people identifiable in these big research studies, but also what approaches there actually are to anonymization and pseudonymization in terms of, algorithms that can actually do that for researchers was quite interesting to consider. And a lot of the things we did was quite fiddly, and we're not the experts on that type of research, but in the end, that's why it probably took quite a long time. Then I want to talk a little bit about two examples now, how we use the sensor data. In the first case, it's about an impact study which was looking at the changes of behaviors during the COVID-19 lockdowns in 2020 and 20 compared to the data which was recorded beforehand. So the idea was that's published in this Journal of International Journal of Environmental Research and Public Health. And the idea was what actually is possible to identify in terms of behavioral changes from the utilities data alone. And I mean, in a sense, it's an interesting question scientifically or academically, but also it has a lot of real implications for example, housing providers, also care service, and if you like, also the government, because if one could use this data from a big cohort and identify that there are changes in behaviors at cohort level, then one could target services in a different way. So we considered these pre-lockdown and lockdown periods in 2020, March and April, and we were comparing these with the data from the previous years to see if there are differences and if they are significant. And the main questions are essentially linking to the volume of, in this case, utilities use, so energy, water, and gas use, if there was some difference, but also if there are temporal changes, if people were behaving differently during lockdown than they were not during lockdown. So in the context of the data that was used, it's effectively not just the sensor data, but also linking it to household data, in particular the number of people in dwellings, as well as the type of the poverty, if they're using smart meters, and some of the survey data we were collecting in terms of, for example, employment status and what time they spend at home. And so then essentially data collected during these periods of time, where if you look at time series graphs, they're usually quite uninformative. There's not much you can read into these. So you need to apply some sort of time series analysis method. And so what we are applying here was a regression method, which was looking at sort of mixed models between the sensor data and the other kind of more qualitative data from the survey factors and features in the survey data and the household data. And so some of the significant findings that were coming out of this was that essentially electricity usage can be used to identify that there were changes in behaviors, in particular with a shift of behaviors within the day, which is not surprising because people were staying at home during lockdown longer or didn't have to leave at all the house, so they were getting up later, and you would see a more condensed day. And similarly for water and gas usage, with a slightly increased usage pattern too, also probably, interpretation is up for grabs, but probably due to more washing, more hand washing, etc. The general idea of this project wasn't necessarily to get onto the sort of, into the behaviors due to COVID, but just to identify ways how we could use the data from sensors to actually identify changing in patterns, because they have sort of higher or implications for certain providers, in particular with respect to health and care. Because if care organizations or the NHS or GPs would be able to access this type of data and identify that there are issues going on in homes, in particular, for example, with respect to heating or cooling or air quality, then they would be able to be more responsive in some sense, or also be able to prescribe better ways to deal with certain conditions. So, for example, it doesn't make sense to give someone who has asthma certain asthma medication if they live in a home which has terrible air quality because of the environment conditions in the home. And then care organizations will also benefit from the idea of monitoring environmental data in the context of targeted services. For example, if you're living in a home that is average too cold, it is not very helpful if you have a physio at home, because that might actually not be beneficial for you. So again, some of sort of an interruption for thought in terms of cyber challenges in this context. If you think of predictive or inference results that would be feeding into from sensor data in homes into sort of end users like care organizations or housing, then obviously there's a lot of things one needs to take care of in terms of data privacy, I guess, but also in a way of how the sensors might be tampered with. I mean, what you heard in the previous talk is certainly of concern, because one needs to be sure that what is being recorded is actually reality. And so I guess the questions we were sort of in particular concerned is how one can try to identify metrics or measures that would be individualized for certain people in homes that can essentially relate to their individual patterns and environmental conditions. So some people like it cold. It's not necessarily that would require some sort of alert or kind of interference. And so a system which is measuring this data would obviously need to appreciate that. And then the other problem I sort of can think of is the I guess the idea of using machine learning algorithms in this context. They need to be sensitive, significant, and you need to have high confidence. But in a way of if you're applying it in the context of care or health, if you would have sensors that can detect falls of people that are frail, then the confidence level or the significance levels in this context might not be should not be too high. Like the thresholds to essentially inform or alert someone in this context can't be so that the algorithm wouldn't be able to detect something that actually happened but then isn't sure about. So in the context of outcomes from machine learning algorithms, there's certainly some kind of work to be done in terms of what that actually means when you share this type of information on. The second example I want to talk about is the kind of overarching interest into helping people to get more included into digital, in particular with respect to care and health. And one of the sort of findings from the survey in general in the Southwest, but I think particularly in Cornwall, is that a lot of people are actually not connected in particular to the healthcare system. Now that there is this transition to more online, in particular also through the COVID pandemic, that might have changed a little bit from when we did the survey in 2017. But still, at the time when we did the survey, there was of the participant cohort, there were more than 20% who actually didn't have internet. So it's quite interesting to look at that from a design perspective. Also, when you think about sensor data in homes, which could benefit people, but if they're actually not able to access data through any kind of means, then one can wonder what's the point. So in the context of what we did was one example was to develop environmental data dashboards, which were trying to effectively help participants to look at their own data from their homes to then take action, but also make it essentially dashboards, make them for care providers or end users in the context of these data, which is a different type of exercise, because one is more of a individual information type presenting for someone who might want to know something about their home. The other is more of a cohort perspective, where it's not necessarily a problem of looking at individual data, but one wants to see the kind of the outliers in the data. And it's not something that is something that is being looked at by not just us. It's effectively also something the industry does. And if you are using sensors in your homes, typically when you buy these sensor sort of systems now, you get dashboard apps from the providers of the hardware too. And ACO was one of the partners on the project we did do some work with. they started sort of not necessarily integrating what we develop, but they already sort of independently looking at this and developing apps for example, housing providers or care providers, which would look at the data in that sense that it's sort of accessible for people who are not necessarily data experts. The overarching aim is this sort of detecting of poor responsive homes is difficult when you just look at weekly lines of time series data. And so what are the processes of visualizing data and making it accessible also in the context of not even visualizing it, but also creating automated alerts and notifications. I guess the approach we took in this context was this co-design living labs approach, working both with the participants in the project, but also the care, housing, public health providers. We ran workshops, we were testing different scenarios with people from real data, what responses they would take to that and how it might be improved, and effectively create sort of easy to use outputs or technology dashboard and app technology that is fit for purpose. And so one of the things in conversations with care providers in particular is that obviously it needs to be as simple as possible, but also the idea of creating automated notifications using essentially machine learning, AI type approaches to analyze the data in the background is certainly something they appreciate. So these are some of the kind of outputs that have been produced. On the left, you see the one from ACO, which is this sort of interactive dashboard with respect to, in particular, a home environment from a housing provider. On the right-hand side, we were looking at working primarily here with HUK, who are more interested in the environment from a health perspective and how that might be beneficial or not beneficial for their clients in terms of helping them with some care or in general, so improving people's well-being. And so one of the outputs that actually sort of has led to interventions was that the data is being used for, in this example, for identifying fuel poverty and helping people with that. And in this case, there was one of the tenants or participants in the study who kind of suddenly had a temperature drop in their home. The data obviously the data was the alerts in the data noticed that and were informing us that there was something going on because it's an unusual event. And so an investigation then went into finding out that the resident couldn't afford paying for the heating. The care provider, HUK, and the housing provider, they helped them to get energy vouchers because they weren't aware of it, that they were eligible. And so then that obviously helped them to heat their house again. And then in general, what we also did was a return on investment analysis using this the Housing Association Charitable Trust database, where they're looking at all types of services and products that are in housing and have, and generally in community that cost money and that effectively can be improved on. And in this analysis, we were very careful to try to link individual things that happened throughout the case of the studies for the last sort of 6 years, to really link that to sensor data and demonstrate that this really was an action based on what people saw or could identify from the sensor data. And as you can see, I mean, it's not that expensive to run relatively large sensor networks. So this was 150 almost 150 homes in almost 2 years, with a few main costs were the sensors of this technology, but also the staffing. But the outcomes are quite significant in terms of helping society, the NHS, council, etc., the housing provider, save money and to generate that social investment. Again, coming to some data challenges in this context is that a lot of small organizations, they don't have expertise in the area. If you think of any kind of cyber security, privacy, etc., they need to look at it obviously from a regulatory point of view, but it's not that they can hire a cyber expert. So it's a question, I guess, for the community to think about how one can develop secure and easy access platforms that are still fit for purpose. Also, what type of training might be useful in this context, and then in terms of that, software and hardware providers, the developers who create this technology, what they would need to consider. So this is just a brief sort of summary of other outputs. We were not just looking into the COVID sort of behavior study, but also, for example, how we can use the data in the context of modeling mold in homes and how that might link to respiratory health, or how one can improve energy provision in homes, how you can get buildings to net zero, which is a big question for a lot of councils in the country. And then essentially generally how it's feasible in social housing, for example, to help with sensor systems. And I guess research ideas for the future are plentiful, and we are currently working with specific cohorts with specific health conditions, in particular, some sort of physical and mental health conditions. For example, dementia, Alzheimer is a big sort of topic currently with helping with sensors. Any kind of sensors, could be wearables, could be environmental sensors in homes, cameras, etc. And they're obviously everywhere there are sort of security and privacy issues, but also the relationship between the indoors and outdoors environment and multiple benefits analysis. So it's not just a care or housing problem, but it's a bigger sort of technology for decarbonization, a net zero type problem too. And I think I will stop here.